Again, we start by factoring. After you factor, you can say what your non-permissible values are. And we have to decide if these non-permissible values are wholes or vertical asymptotes. Nothing cancels out. They are both vertical asymptotes. Next, horizontal asymptotes and oblique asymptotes. Look at your original equation because nothing canceled out. Do you see that you have the same degree on the top and the bottom? A degree of 2 up here, a degree of 2 down there. And if we just look at the leading coefficients of that highest degree, that's going to tell us we have a horizontal asymptote at y equals -2. And once I've done all my asymptotes, that's when I like to start graphing. So 1, 2, 3, 4, 5, 6. I'll put my asymptotes on there. Next, y-intercept is the easiest to find, so I plug in 0 for x. My original equation gives me 0. Which happens to also be my x-intercept, and the only x-intercept that I have, right? So y-intercept, I plugged in 0 for x, and I got 0 over -25, which is 0. X-intercept, I plugged in 0 for y to see if there was anything else that could possibly make it 0. And there isn't, because the only thing that would make my numerator 0 is 0. So, I've got 0, 0 as my only point. I need to find some other nice points. I might plug in section 1, -6. What would happen if I plug in -6? I'll take out my orange pen here. Maybe I'll use my original. Oh my goodness. See, that would be -72 on the top. I plugged in -6. And 36 minus 25, 11 on the bottom. Okay? So I get -72 over 11. Mental math, can you see that's going to be -6 point something? 4, 5, 6, 7. I'm going to go to my graph and put that point on there. -6, comma, -72 over 11. And that's enough to say this section looks like this. The reason I like using the original equation is that, can you see that plugging in a negative number like -6, because it's getting squared, it's going to be positive 36, is going to be identical to plugging in positive 6. So I get 6 comma -72 over 11 as well. That's a nice point here in section 3. Now the middle section is a little bit unclear, right? I have a bunch of possibilities. I could have it hit this dot and go up towards both asymptotes. I could have it go down and swoop through this dot. I could have it go up. Are you confident that you know which way it goes? It can go through an asymptote in the middle, right? Horizontal asymptotes are not non-permissible values. They just talk about end behavior. So if I'm a little bit unsure, then I can just find some more nice points. And I might plug in I might plug in -4 and see what I find out, and I'm like, oh, whatever I plug in for -4 is going to be exactly the same for 4. So I'm going to go up, erase the orange that I had before here. And if I plug in a -4, -4 squared is 16 times -2 is -32. And 16 minus 25 is -9. So this becomes positive 32 over 9, which is 3 point something. So if you're unsure, plug in another point. And it will tell you which way you should make your graphs. Something that you might notice here connecting to our first unit. You notice that it's bouncing off that x-intercept? Does it make sense when you look at your numerator that x equals 0 would have a multiplicity of 2? And when graphs have a multiplicity, an even multiplicity, 2, 4, 6, 8, it bounces off that x-intercept. So we see some of the stuff of chapter 1 also can be applied here and show up in chapter 2 as well. Okay, this one, circle number 4.